Well, we have this great opportunity to be working with two collaborators, two scientists that are co-authors of this grant with me. One is Dr. Oliver Pfister at University of Virginia. He's in the physics department over there, and he's really a kind of a combination theoretical experimental physicist doing quantum optics, doing experimental quantum optics for the goal of quantum computing. And quantum computing has been around for a little while in concept, but really the technology has started catching up to the point where you can envision in the near future, being 20, 30 years, having an actual real quantum computer in existence. And so in thinking about how you might build a quantum computer, Dr. Pfister and I and Dr. Sae Woo Nam at the National Institute of Standards and Technology in Boulder, Colorado, co-wrote a grant that would allow us to work together in a collaborative way to use everyone's expertise, individual expertise, to best achieve in the next 3 years steps toward building a quantum computer using lasers and photonics. So using light, using laser systems that Oliver Pfister at Virginia has really pioneered for doing many qubits, so large computations, using these complicated states of light to make the computation. And the part of it that we fit into is then, as part of my research background, really making the advanced photon detection system. So making the detectors that see the light, because you can generate the light, you can compute with the light, you can manipulate it, but then you also need to detect it once it comes out of the computer, if you want to call it that, and see that light as it comes out, and use that light for doing analysis at this point to see if this is a feasible way to do this computation in the future.
It was very interesting working with equipment that I knew could do so much. And before this, I had never worked with anything this big, I suppose. It was really interesting, like, writing the programs and figuring out the programs to get them to collect the data, sort the data, and record it, as well as using other programs to analyze it and figuring out what that meant. This is really the first experience I've had doing research like this and collecting actual data. I think the advantage of being at a smaller school is working much more closely with the professors. The main reason I came to Albion is because I saw that the professors were people who worked with the students as people. They weren't on a completely separate level, they were just the instructors, and they helped the students as people and worked with them. And I don't think I would have gotten this opportunity to work over the summer doing research like this if I'd been at a larger school.
So I think that's one of the parts about being at a small school that's very exciting for both the faculty member and the students typically, is being able to work very closely with one another, not for some perfunctory exercise, but for actually accomplishing a goal together, and that's part of the scientific collaboration. It's an integral part of what science truly is as a collaborative process.